Welcome back to another video. So in today's video I will be answering a question paper from the 2024 March question paper that was written in KwaZulu-Natal. So this is the paper. As you know, I will be answering a question with regards to vertical projectile, but you know they mix it with Newton's law from grade 11. So that is the question that we will be answering for today, and this is the question 2 that I will be answering, and reminding you guys about normal force, gravitational force, applied force, frictional force, kinetic force, all of those things. So yeah, let's tackle this video first. But before that, let's read this. Please don't forget to like, comment, and subscribe. A learner constructs a push toy using two blocks with masses 3 kg and 5 kg respectively. So the other one has 3 kg and the other has 5 kg. The blocks are connected by means of a light inextensible string. The strings move over a frictionless pulley. The learner places the 3 kg block on a plane that is inclined at an angle of 30 degrees to the horizontal. So the 3 kg is placed at an incline at an angle of 30 degrees. He then applies a force of 60 newtons at an angle of 20 degrees to the 5 kg block by means of a light rigid rod, causing the toy to move across a flat, rough horizontal surface as shown in the diagram below. So there is the diagram, and then the coefficient of kinetic friction between the surface and each block is 0.15. So we are having the coefficient of the kinetic friction. Okay, you need to know the kinetic friction, so which means this thing is moving. Kinetic friction is when an object is moving, and then static friction is when it's standing still. So we're given the coefficient of the kinetic friction, meaning that these things are moving. So in 2.1 we are asked to state the Newton's second law of motion in words, and in 2.2 we are asked to draw a free body diagram indicating all the forces acting on the 3 kg block, and in 2.3 we are asked to calculate the magnitude of the normal force acting on the 3 kg block. Yeah, 2.3.2 we are going to this is 2.3. We're going to calculate the magnitude of the normal force acting on the 3 kg block, and then 2.3.2 the kinetic friction force acting on the 5 kg block, and then 2.3.3 tension in the string connecting the blocks. Okay, so that's what we are going to be doing. So let me refresh your memory a bit. All right, so let's say for instance that we have an object, a box. Let me take it down a bit. A box sitting on the ground. Okay, so with this box in the center of the box, we will have a line going down. That line is called gravitational force. Okay, this is a big F and a G. So we have gravitational force is what keeps the body on the ground. So it's keeping the box on the ground. Then going up high, we have what we call normal force. Okay, normal force. And then if the box is being pushed from the left to the right, let's say the person is standing here and is pushing this box, we'll have that to be this direction. This will be the applied force, okay? And then here at the bottom, we'll have something called frictional force. Frictional force is stopping the box from moving. When you're pushing something against a rough surface on the ground, there is frictional force trying to prevent the box from moving to the direction in which you want it to move to. So you are moving it towards the right hand side. The frictional force is trying to make sure that it doesn't go forward, that it goes back. So this is the free body diagram of a box that is sitting on a flat surface being pushed towards the right. Okay, so let's talk about a box that is being pulled. This person is pulling the box towards their direction. It's still being pulled towards the right, but they're now pulling it. Okay, so when they're pulling it like that, that's when we have applied force. This side, from the middle going up, we still have gravitational force, and then high we still have normal force. And then this side we can have our frictional force. The frictional force is trying to prevent this box from being pushed to the right. It's trying to stop it. Okay, so this is how you will have your diagram. Now we can talk that if we have, let's say we have an angle like that, and then it's 30 degrees here, and then we have our box like this. Normally it will be pulled upwards. So if the box is being pulled upwards with a string, then we are no longer going to have an applied force, but we are gonna be having something called tension force, because there is a string. Because it's been pulled with a string, so there is a tension that is taking place there. Okay, it's no longer applied force, but there is tension. So remember that. And then you will still have your gravitational force, and then you still have your normal force up here, and then you still here have frictional force. So this is how you do it. But when it's moving, you can also write this as kinetic force, because it's moving. Okay, so you can also replace that with kinetic force. Yeah, I hope you are finding this information quite informative, so that we can be able to answer the questions that we have. And another thing that you have to know is that, okay, when the box is in a flat surface like that, normal force is equals to gravitational force. Okay, and then when we are having the box in a flat, but this box is being pulled at a surface like that, you see, and then here let's say we have 30 degrees, so it's being pulled up. We have 10 newtons there. Then normal force and gravitational force are not the same. Okay, just know that they are not the same. Since they're not the same, you need to find this part here. Okay, you must find this part here, which is y. And then we're going to write sine. We have the angle of 30 equals to, when you remember, so ka 12. The sine is opposite over hypotenuse. So here we are going to get sine 30 is equals to y, which is opposite to this angle, and then hypotenuse is the longest side, it's 10 newtons, and we are going to, here we have sine 30. So what we do here, we are going to cross multiply, and then we will have 10 sine 30 equals to y. Equals to 10 goes with this, and then y goes, we'll say this is over 1. Okay, so that is what we are going to do, and then equals to y. So we punch this into the calculator, then you find that 5 newtons equals to y. Okay, so when we have found this 5 newtons, that will go for gravitation, not gravitation, that will be our normal. We will take gravitational force plus this 5 newtons, and that will give us our normal force. So gravitational force plus this 5 will give us our normal force. Let me show you how you get your gravitational force. So gravitational force equals to mass times gravitational force. So Fg equals to mass, it's 5. Let's say the mass of that box is 5 kg, and then we multiply it by 9.8, which is the force due to gravity. You punch that in the calculator, you're going to get 49 newtons. That is gravitational force. But then normal force will equals to 49 plus that 5 we calculated, and that will give us 50. Yes, I've shown you that. Now we're going to try to answer this question. Let's state Newton's law in weights. Before that, let me erase that so that we can say 2.1. Newton's second law in weights says okay, so 2.1 says state Newton's second law of motion in weights. So 2.1 says the Newton's second law says when the net force acts on the object would accelerate in the direction of the force, and acceleration is directly proportional to the force and inversely proportional to the mass of the object. Okay, or you can still say the force acting on a body is equal to the mass of the body multiplied by the acceleration of its center of mass. That's Newton's second law. You can use that one as well. Now 2.2 says draw a free body diagram indicating all the forces acting on the 3 kg block. All right, so if you've done this, remember this is being pulled at an angle. Okay, so it's being pulled at an angle, so we'll have a dot in the middle. We ask for a free body diagram, and then in this free body diagram we have tension being pulled up. This is tension, and then we have normal force going this direction, and then we have kinetic friction because it's being pulled, it's moving, and then we have gravitational force. So it's not on a straight line because remember this is going up like this. There is a box, so this one is going like this, this one is going like this, this one is going like this, and this other is going like this. So we don't have a straight line like that. Okay, yeah, so I will show you this graph might not be the best, to say the least. May not be the best graph I can draw, but let me try to make it a bit better. Yeah, so we have tension going up, we have frictional force, we have kinetic friction, trying frictional force, kinetic friction, trying to stop the object. And then yeah, we can just do it like this, and then this will be gravitational force. No, it's still fine like this, guys. We have tension, and then we have Fn, and this side we have Fk or Ff. Okay, frictional force or kinetic force, whichever one you choose, it's okay. So in the memo they have stated them like this. So it's either you accept the first one or the second one. So you're going to be marked when they want a free body diagram. They want you to show that you know the normal force, gravitational force, and all that. So they want to know you know what is being applied there. With the parallel ones, it's for grade 11. The grade 11s will still remember that because they are still busy with them, but grade 12s, because you're not going to be taught this topic like that, they will still mark you if you do it like this. But if you remember the parallel and perpendiculars of grade 11, then you must use that. All right, so 3.2 say calculate the magnitude of the normal force acting on the 3 kg block. So remember, when you are not pulling at an angle, normal force and gravitational force are the same. So here we have a box that is being pulled. Even if it's like this, it's being pulled at a straight line. So gravitational force and normal force are the same in these instances. Okay, so we're gonna say normal force equals to mass times gravitational force, and then cos theta. Where the cos theta is coming from is because of this angle here. It's above angle theta. But if we do not have angles and it is on a flat surface, then you don't have to include the cos. Okay, but because it's at an angle, you need to say cos theta. So normal force equals to the mass is 3 kg, and then gravitational force is 9.8, and then we have cos 30. So you just punch that into your calculator and you'll get 25.46 newtons. The acceleration due to gravity is 9.8. That is the one that we use. That A stands for that thing. So here is 2.2. We have calculated the normal force, and then here we can have 2.3. Yeah, let's take it up like that, and then we are going to do 2.3. We are asked to calculate the kinetic frictional force acting on the 5 kg block. So kinetic friction equals to we have K here, and then time is normal force. Okay, so we are going to use the coefficient, which is 0.15, and then multiply it by normal force. Okay, yeah, so that's what we're going to do. Fk equals to, when we substitute, we use brackets, 0.15 times 5. The mass we asked for, the 5 kg, times 9.8. Okay, times 9.8. All right, just look at that, 60 newtons. Remember, when we are trying to calculate normal force, when something is being pulled at an angle, now the 5 kg block is being pulled at an angle. Okay, so we have to include the 60. We'll say the 60 and the sine 20. Okay, so let's me just try to show you. The 5 kg block is being pulled at an angle. We have 20 here, and then here it's 60 newtons. We need to find this part with the dotted line. Okay, so normal force is gravitational force for this box. We're going to do it for this box, so it's 5 times 9.8, and that is going to give us 49. After that 49, and then we're going to say yeah, we're going to say sine 20 for this angle here, so that will be sine 20 is equals to opposite over hypotenuse, and then sine 20 equals to, we don't have the opposite, but we have the 60, hence we have 60 sine 20. So this is what you will have there. Okay, so that is what we will have there, 60 sine 20. That's where it's coming from. I hope you understand, guys. It's very important that you understand these things. Yeah, so here let's try to do it a bit smaller. So we say kinetic force equals to 0.15. This is the coefficient, or times 5, 9.8. yeah, that is for that, and then we have 60 sine 20 degrees. So this simply means that this side is the gravitational force of the 5 kg blocks, and then this side is the gravitational force plus this number that we're going to get here. Okay, let me put it, plus the y that I show you that we have to get, that is 60 sine 20, and that is 20,251. Okay, so that is what we were looking for. Here we have them. So kinetic friction equals to the coefficient times normal force. So this calculations that I did here is the one that I just did previously. Okay, but we didn't have the 5.8 is what we did previously. We just didn't have them 0,15. So we're adding the 0,15 to complete the whole thing, and I hope you guys are understanding. So when you put that in a calculator, Fk will equals to 10,34 newtons. So now we can do 2.3.3. So from the memo here you have 2.3.1 and 2.3.2. So we'll do 2.3.3. So here we look at the tension in the string connecting the blocks. So that is the string, that straight line, that is what we want to calculate. Tension in the string connecting the blocks. So with this tension in the string, we have to choose whether left or right is positive. So you have to know whether left or right is positive for you to make this calculation. So we will say left is positive, negative, and right is positive. Okay, so that is what we will conclude. Left is positive, right, left is negative, right is positive. So remember the free body diagram. Anything that is in the right will be positive, anything that is in the left will be negative. So we are going to use this formula. So we'll say tension friction. If it was applied, we would say applied friction minus gravitational force, because it's in the left hand side, and then it's a negative, and then we have plus another a negative kinetic friction, so will also be negative because they're in the left hand side, equals to ma. Remember guys, it was normal, it was kinetic friction, it was also gravitational force, and then we had tension. So tension is in the right, we say is positive, these ones are negative. Okay, hence we have what we have there. So this will be the formula. So you punch in everything you have in this instant. So we don't have tension, we are looking for it, but then we have gravitational force, which we calculated in 2.3.1 as 25,46, and then we also have plus the negative 0,15 is the coefficient that we were given. Let's do this. So sorry, this 2 will be the this is the kinetic force, sorry about that. So let's start with the gravitational force. We'll have the 3 times 9.8 sine 30. All right, so this is the gravitational force for the 3 kgs, and then we will have the negative 0,15 for the kinetic times 25,46 and this will be equals to the mass is 3 and then A. We do not have that A, okay? And then we'll say tension equals to, when you punch all of this in the calculator, this thing, it's going to, it has to give you 18,52. That is what you need to get. All right, so we'll just take it to this side. So we'll have 3A plus 18,52 because it's going to be negative, so we make it positive by say 18,52. so that will be equation 1. So guys, if you are given this and you're asked to calculate the kinetic friction, you're asked to calculate the gravitational force, you use the F net equals to ma. Okay, whenever you're asked to calculate the mass as well and you're given the tension, the gravitational force, this is how you calculate it. Remember, okay, keep that in mind. So here we are asked to calculate the tension. Now let's go further. This is for the 3 kg. All these calculations are for the 3 kgs, and now I'm gonna have calculations for the 5 kgs. You still have F net equals to ma for the 5 kg, and then we have Fk here as well, plus negative kinetic friction, you can still do it like this, minus tension equals to ma. So we have the 60 plus no here it's not k, sorry, I'll just write it fx, but we know and then here I'm going to say 60 cos 20, this is the calculation we did, minus 10,43, okay, minus t equals to ma. You can always go back to the calculations that we did, is equals to 45,95 minus, oh sorry, here I'm supposed to have 5 minus 5a. So because this 60 cos 20 minus 10, it's positive, it's not positive, yeah, it's negative, so we take it, we take them to the others. Let me do this. Yeah, it's positive. 60 cos 20 minus 10, 43 is positive, so we take the t because it's negative to the other side, then the 5 to the other side. That's what happened there. So we have tension equals to 45,95 minus 5a, and that is your equation 2. So we have two things which are unknown. So t equals to 45,95 minus a, and then t is always equal, it's also equals to 3a plus 18,52. So here is what we're gonna do here. T is equals to we're not even gonna write t because they're both t. We're going to write 3a plus 18,52 equals to 45,95 minus 5a. So we will have 3a plus 5a. Like terms, we have 45,95 minus 18,5. 2. Then put that in the calculator. Here we'll have 8a equals to 45,95 minus 18,5. 2, and that will be 27,43. Yes, and then what we'll have here, we'll divide by 8 to have a by itself. And then here will be 3,43 meters per second. You see, so you can substitute any of those equations. So we'll say 3, we'll use a 3 kg into 3,43 plus 18,52. Then T is 28,81 newtons, or we can use that T equals to 45,95 minus 5 into 3,43. It will still be 28,80 newtons. It is, guys, 2.3.3. Sit down, make sense of this whole thing. It's very easy. I hope you enjoyed the video. Until the next one, we will be doing question 3, which is throwing a ball upwards, vertical projectile.